Okay, so we're going to find the inverse of our functions here. I look at my original graph, and all you have to do these is switch your x and your y. So for my first function, I look at my points. I have, for the first one, I have -1, -1. I have 0, 0. I have 1, 2, 1, 2. I have 2, 6. Another feature of this graph it does have an asymptote at y equals -2. That'll come into play in a moment. Now, before I move on to the graph, first off, it says, is the inverse a function? You can actually tell if the inverse is a function even before you graph the inverse by drawing a whole bunch of vertical lines. So, and you can tell, well, my original graph is a function because it passes the vertical line test, which means when I draw vertical lines, it only intersects the graph once. But also you can tell if the inverse is a function if my graph also passes the horizontal line test, which my graph does. It only intersects my horizontal lines only intersect my graph once. And so that's how you know that the inverse is also a function without actually graphing the inverse. So you do both the vertical and the horizontal line test. The vertical line test is just to see if your original graph is a function, but the inverse is a function for this one. When it passes both a vertical and horizontal line test, it is called a one-to-one function, which means every input has an output, every output has exactly one input. Okay, so what you do with the points is you reverse it. So this was -1, -1. You're not going to be able to see it here with the first few points because they're the same, but then we end up with 2, 1 and 6, 2. My asymptote, interestingly enough, instead of y equals -2, it's going to be x equals -2. Okay, so I'm going to start with my asymptote. This is the line x equals -2. Every point in that line, the x value is -2. So I know my graph is going to get closer and closer to that. I graph my points. There's my -1, 1, my 0, 0, which isn't much different. I then have 2, 1, where they kind of start to diverge, and then I have 6, 2. And so I kind of connect them. Now be really careful when you're writing your points down. It's kind of important to write your points in order so you know how to connect the parts of your graph. Okay. The other thing is there's a nice little check built in as far as symmetry goes. So if I draw a line along the line y equals x, so the line y equals x is 1, 1, 2, 2, 3, 3, -1, -1. What you'll notice is that first off, the graphs intersect, both of them intersect as they cross that line. But also, if I fold my graph along that line, it folds on top of itself. And so the graphs are actually reflections of each other. A graph and its inverse are reflections of each other because y becomes x and x becomes y. So going to number 2, I'm going to go through the same thing. It's -1, 1. And it's going to be 8, 2. And this one also has an asymptote, but instead of y equals, it is actually at x equals -2. There are other asymptotes besides at -2, it's just these two examples have to have those. For this one, I'm also going to start with the asymptote. Now, just before we continue, it says this is the inverse of function. Well, if I drew a whole bunch of vertical lines, they'd only intersect at once. And if I drew a whole bunch of horizontal lines, it would only intersect at once. So I already know that the inverse is going to be a function because my graph is one-to-one, passes both a vertical and horizontal line test. But you can look at the individual inverse and just see if it passes the vertical line test. So I have 1, -1. So 1, -1, and then I have 2, 8. So I have 2 and then 8. And I'm just going to connect my points together. And as I connect them, I know that this one is going to get closer and closer and closer. Okay. And so I kind of do my little check. I go through And I just draw a line along y equals x. I'm just a little off. So, but if I draw my line along y equals x, you'll see that little off. I just my shape a little bit. But that if my graph kind of folded, it would fold on top of itself. And my blue graph here does pass both the vertical and the horizontal line test. So let's go down to the bottom ones. The graph function is given below. Sketch the graph. Okay, look at this. I know for this one, it is actually the inverse is not going to be a function because it does not pass. My graph is actually not going to pass although my original graph does pass the vertical line test, it does not pass the horizontal line test. And I think this is a good counter example. Do you see that if I draw horizontal lines, it actually intersects my graph more than once? So the inverse is not going to be a function because my original graph does not pass the horizontal line test. So we're actually going to get rid of that. Okay, so we're going to say no. Okay. Working through here, I'm going to write down my points, especially for this one. Make sure that you write your points in order. So that's going to be 1, 2, and then we have 2, -1. We have 3, -2. We have 4, -1. We have 5, 2. Those are all my important points. There are no asymptotes or anything here. Okay, so my new points are going to be 2, 1. Okay, -1, 2. So -1, 2. -2, 3. -1, 4. And 2, 5. Wait, 2, 5, sorry. 2, 5. Okay, just be careful. So again, I go through, I connect my points. I can tell that the inverse is not a function because if I draw a vertical line, do you see that it does intersect it more than once? So it definitely is not a function. Okay, and we can do our little check here where we graph the line y equals x. And you guys will see that it does, okay, it does reflect on top of itself. Okay, my last one's here, a little tricky, just because of how you connect the points, so be very careful with this one. No asymptotes. Is the function in inverse? It is going to be, is the inverse a function? It is going to be yes, because if I draw my vertical lines, it only hits it once. If I draw a whole bunch of horizontal lines, it's only going to intersect it once. So it does pass both the vertical and the horizontal line test. Okay, so this is a big no right here. Now I make sure that I write these in order. So I have -1, -6. I have 0, 1. I have 1, 2. I have 2, 3, and I have 3, 10. Okay. For my new function, I reverse it, so it's going to be -6, -1. So -6, -1. I have 1, 0. So 1, 0 is here. I have 2, 1. 2, 1. I have 3, 2. Okay. And I have 10, 3. Okay. So I know that my graphs are kind of moving away from each other. I know this, because it's a mirror image, is going to go like that. And then it's going to kind of go this way. Okay. Because I know that they're mirror images, if this part is moving away, then this part is kind of moving away. If this is getting close, this one is getting close. So there is your inverse. Okay, so that's graphing. We're going to move on to the algebraic methods. The algebra isn't too bad. Only thing you have to remember to do is basically a lot like the graphs. You switch your x and your y, but then you solve for y. So you just rewrite it completely. So this is going to be x is equal to 2y squared minus 1. Okay, you go through reverse order of operations. This is all, I have minus, so I'm going to add 1 to each side. I can't combine the x and the 1, so it's going to be x plus 1 is equal to 2y squared. Okay, I divide by 2, divide by 2. I end up with x plus 1 divided by 2 is equal to y squared. And then we do the inverse operation, so we take the square root of each side. Y is equal to the square root of x plus 1 over 2. And that's your final answer. You can actually leave it. There won't be much simplifying when it comes to these. So we do the same thing with the next one. This is going to be x is equal to y squared plus 5. I subtract 5, subtract 5. So this is x minus 5 is equal to y squared. Take the square root. Y is equal to the square root of x minus 5. And that's your final answer. These two aren't too bad either. This is x is equal to negative 5. Negative 5y. I don't know why I'm having so much trouble with 5s. I subtract 3, subtract 3. X minus 3 is equal to negative 5y. Divide by negative 5, divide by negative 5. And so you have two possible answers. It's going to either be y is equal to x minus 3 over negative 5, or you could have something like y is equal to negative x over 5 plus 3/5, where you divide each part by 5. This is probably the trickiest one, only because your brains fall out of your head when you see fractions. So this is equal to, x is equal to 4/3 y minus 8. I add 8 to each side. So it's going to be x plus 8 is equal to 4/3 y. Then I multiply by the reciprocal, so I multiply by 3/4. And I multiply this whole side by 3/4. Okay, what the biggest mistake that students make is they don't remember to do distributive property. Okay, what the multiplying by 3/4 does is it gets rid of dividing by 3, it gets rid of multiplying by 4. So what I'm left with is I'm just left with the y there. On this side, then I do distributive property. It's going to be 3/4 times x plus 3/4 times 8. Okay, y is equal to 3/4 x. Now if you multiply across, is going to be 24/4. So your final answer is y is equal to, remember you can use calculators, don't get so bogged down by fractions, 3/4 x plus 6. And that's going to be your final answer for that. So we're done with inverses.